19. Same note sheet from yesterday. So we're starting off with this. Now the second one did not have a denominator written to start with, but we know that it's going to be 1. Homework number 19, 731. Now our x squared minus 49 is a nice one to factor because it is a difference of perfect squares. So our signs are opposite, x and x, 7 and 7. Now we can multiply either, or do our factoring for either numerator first. It doesn't matter which one we do. If we do x squared plus 5x minus 36, since our 36 is negative, our signs are opposite. The only factors of x squared that we can have are x and x. 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't work, but 6 and 6. Which one do we want to try first? Well, 9 and 4. And if we check this here, x times negative 4 is negative 4x. 9 times x is plus 9x, giving us positive 5x. So those are the correct factors. The other one, x squared minus 11x plus 28. Since the third term is positive, our signs are the same and match the sign of the middle term. Factors of x squared are x and x. Now 28 is 1 and 28, 2 and 14. 3 doesn't work, but 4 and 7. We can use 4 and 7 if we check this middle term. X times negative 7 is negative 7x. Negative 4 times x is negative 4x, giving us negative 11x. Questions on how we factored any of this here? Okay. Now at this point here, we can multiply all this together. Now the denominator is going to be x plus 7, x minus 7. The numerator is x plus 9 times x minus 4 times x minus 4 times x minus 7. But we only have one thing in common on top and bottom. X minus 7 and x minus 7. Thus leaving us with x minus 4 times x minus 4 times x minus 4 over x plus 7. It's going to be after next week. 7, 5.
We also look at 20. On my paper.
All right, guys, we're looking at number 20, and then we're going to get started and finish this here. Now, again, just like the previous one, we need to factor. And the first one I would look at factoring is x squared minus 16. Now, since it is a difference of perfect squares, it's going to factor to x plus 4 and x minus 4. And we can look at the numerator, x squared minus x minus 12. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Now factors of 12, 1 and 12, 2 and 6, 3 and 4. Which one do we want to try first? I'd go with 3 and 4 because if we put it 3 and 4 or 4 and 3, either way, we do get something in common on top and bottom. Now, if we check this here just to make sure, x times negative 4 is negative 4x. 3 times x is plus 3x, giving us negative x, the middle term we wanted. So those are the factors that we want. Now, the denominator of our second expression is 1. Now, when we factor x squared plus 2x minus 8, third term is negative, so our signs are opposite. Factors of x squared are x and x. Factors of 8 are 1 and 8, 2 and 4. Now, at this point here, we can use the denominators to help us. Well, at this point, we already know x minus 4 and x minus 4 are going to cancel out. So if anything else is going to cancel, well, we would use the 2 and 4, and the 4 would have to be positive and the 2 negative, because the x minus 4 has already been used. Now we can check this still to make sure. X times negative 2 is negative 2x. 4 times x is plus 4x, giving us a positive 2x. So that is the middle term we wanted. As we've already seen, the x minus 4 over x minus 4 here is gone. That's simplified out. And so far, all that's left in the denominator is x plus 4. Our numerator, what we have left when we multiply, is x plus 3 times x plus 4 times x minus 2. Well, now we have something in common on top and bottom, our x plus 4. And when that reduces, we're left with x plus 3 times x minus 2. Since they were left in the numerator, we don't have to write a denominator of 1, it's just understood. Questions on this here? All right. We're going to continue on with our notes. We did this one yesterday. Yes? Because I think this is where we finished yesterday. So we're going to do another example of difference. And the first thing we need to do is factor the denominators. So we need to factor our x squared minus 3x plus 2 and our 2x minus 4. Which one do we want to factor first? 2x squared minus 3x plus 2. Is there a greatest common factor? No. One of the giveaways, or kind of ways that we can tell as well, we have x squared. There's not a number in front of it. And the third term, 2, doesn't have a variable, so there's nothing in common. Since the third term's positive, our signs are the same and match the sign of the middle term. Negative and negative. Factors of x squared are, and the only factors of 2 are 1 and 2. Bless you. And we could check it, and this will give us a middle term of negative 3x. Now we need to factor 2x minus 4. How would that factor? We can factor out the 2. There's a greatest common factor of 2, which leaves us with x minus 2. Now, for the most part, I felt like yesterday we were getting the hang of, we understand how to find the least common denominator, yes? However, I still think some do find it a little confusing, so let's look at it a little bit differently. Now, when we look at the two denominators, what does the one on the right have that the one on the left does not? So what does this right side have that this one doesn't? Because y'all said it. Because the right side has a 2, the left side does not. But they both share that x minus 2, yes? So they have that. And they both have it once, so that's fine. The left side's missing a 2, the right side has it, yes? Let's flip it. What does the left side have that the right side doesn't? Yeah. That's it. And this works especially if everything is factored all the way down. If we have it factored all the way down, we can do that comparison. It is a little tricky if we're looking at, say, numbers for like, if we're comparing 6 and 8, because we can't just say 6 and 8 because they do share something in common. Because they both share a common factor of 2. Because we can't just say 6 times 8 to 8 times 6. Because our 8 times 6 is 48. But the first number we can actually turn them both into is 24. So this works very well with our expressions. And it gives us what we need to multiply by. And when we multiply the denominators, we get 2 times x minus 1 times x minus 2. The right-hand side. Two times x minus 1 times x minus 2. And we are going to multiply the numerators. We are going to be multiplying the 2 by our 5x minus 1. And our negative 2x minus 1 is going to be multiplied by our x minus 1. Questions on how we got to this point here? Now we're going to multiply our numerators out because with addition and subtraction, we actually do have to add or subtract like terms in the numerator. We do not have to do that in the denominators. Now our 2 times 5x is 2 times negative 1, negative 2. In our other numerator, we will have to distribute this out. Negative 2x times x is squared. Negative 2x times negative 1 plus 2x. Our negative gives us a plus. 2x times 1 is 2x. Negative 1 times x is negative 1x. And negative 1 times negative 1 is plus 1. Now before we actually subtract, let's combine like terms. Our negative 2x squared does not have any like terms. But our 2x and negative x are like terms. And 2x minus x is plus x plus 1. Questions on how we got to this point here? Now at this point we're going to subtract. Now our denominators, since they're the same, are just going to become 1. 2 times x minus 1 times x minus 2. And we're going to subtract our second numerator from the first. So we're subtracting our 2 numerators. And again, with subtraction, it is going to be good to use parentheses as a reminder to us that the second signs will change. The second one's signs will change. Because when we subtract our negative 2x, and that should be squared, the negative makes it positive 2x squared. When we subtract our positive x, it makes it negative x. And when we subtract our positive 1, it makes it negative 1. Questions on this here? Combine like terms. 2x squared does not have any like terms, so it stays 2x squared. 10x minus x would be plus 9x. Negative 2 minus 1, negative 3. Now at this point here, we need to see if we can factor 2x squared plus 9x minus 3. It doesn't look like we can, so one way to check and make sure is our b squared minus 4ac. Because we plug this in and get a whole number, it is factorable. Well, incidentally, I already have it typed in. And it tells us it's the square root of 105. Well, that means it is not factorable. Right. And really the part of the reason, or kind of why it comes down to that, is we did this yesterday with x squared plus 3x minus 4. And when we took the square root of 3 squared minus 4 times 1 times negative 4, we got this expression was 5. And part of the reason is, and the reason that works, well, I'll get myself enough room, I really didn't. Let's put 5 there. Is this here is part of another formula. Because it's our negative b plus or minus square root of b squared minus 4ac all over 2a. Because when we do get that 5, well, this is negative 3 and 2, we get whole number answers. Now, went too far there. Because what we're saying is x is equal to negative 3 plus 5 over 2, and x is equal to negative 3 minus 5 over 2. Well, negative 3 plus 5 would be 2 over 2, saying x is 1. Negative 3 minus 5 over 2 is negative 8 over 2, saying x is negative 4. Now, if I subtract 1, this seems, I get this here, and I add 4 here. X minus 1 and x plus 4. X minus 1 and x plus 4. Because I think if you, I know some of you have it, the notes from yesterday, we get this. Now our starting equation was x squared plus 3x minus 4, yes? If I factor this, since the 4 is negative, our signs are opposite. Factors of x squared are x and x. 4 is 1 and 4 or 2 and 2. Which are our factors, yes? We get to the same spot. So really what this is saying is, since this is a whole number, it works out that we can factor it. Now if it was, say, 5 squared of 2, is there any way I can still simplify like I did before? Well, no, they're not like terms we have to turn into decimals. It doesn't work out, which means that's not an option anymore. So that kind of makes sense. And that's why that's nice, is we could have yesterday used the fact that it's 5 and then worked it all the way down to find it. Or we're like, okay, since that's 5, that means it will solve out. We'll get 2 nice numbers that we could go back and do that. But it also means that this will factor this here. If it doesn't, it means that it's not going to factor. That's the whole thing behind that. Questions on this here? We ready for a difficult one? Just a 6. There we go. No purpose. So if we look at this here, we need to get the 2 denominators to be the same. Now 7 and 4. We need to see what is the first number we can make both of them be the same. And just like
28.
It's 28. Because we can somewhat use greatest common factor also. Is there a common factor between 4 and 7? No. So that means that the first number really that's going to make them be the same as well. 4 times 7, 7 times 4. Because if you notice with 3 and 9, we did this the other day. What's the first number we can turn both 3 and 9 into? 9, right? But 3 and 9 have a greatest common factor of 3. There's something in common. So just multiplying them will not get us what we need. Because if we just did the multiplication, it would be 27. That's a factor of 3 greater than what we need. We have an extra one. Does that make sense? Anything else we're missing for greatest common factor, or not greatest common factor, that we need to make the denominators be the same? Right, so what we're missing is an x. And we put it with 4x. Because on the left we have 4 and we have the x. So on the right side we do need the 7, 4 the same, and we also need that x. Now we can do our multiplication. 7 times 4x is x. 7 times 4x is our numerator. 7 times 3 is, yeah, you can just put it on my desk. Thank you. 1 times 4x. Now with this subtraction problem, parentheses don't add a whole lot. I'm going to go on, put the parentheses around both. Well, the 21 is just going to be 21 because there's not a negative sign in front of it. But we will change the sign to 4x, which is because we're subtracting it. Now this one, unlike the last one, if we had just said when we did the subtraction 21 minus 4x, that'd have been fine. Because the term we're subtracting, this 4x, is just one term, unlike the last one where we had 3. The parentheses is helpful just to make sure we apply that negative to every single term it's supposed to be applied to. Here, since it's 1, we do the minus, it's there. Does that make sense? Now, before we finish, is there any way to factor our 21 minus 4x? Is there any common factor between 21 and 4? No. So that's it. Questions on this here? Questions on anything we've done so far? I don't know. We can do more of these, but I'm going to give you all the rest of the time to work on the assignment. Because I think using this time to work on it. And if you do have questions or hit a roadblock, please ask.